In this lecture, we are going to discuss about how to calculate the constants, and then we will see how to solve a problem based on this. Let's start. Constants. There are two types of constant we are talking here. One is what we call Km, another one is called Vm. So we all know that Km is nothing but the rate constant, it's a constant, and another one is this is constant. Another one we call the maximum rate of reaction. So before we go into how to calculate this, so what is the significance of Km and Vm? So the Km is normally used to measure the affinity between your enzyme and substrate. So what is this is all about? So there is an inversely proportional relationship between the Km and affinity. So whenever the Km value is higher, it means that particular substrate has low affinity towards its particular enzyme. So that's why I mentioned that there is an inversely proportional. So what is the use of this? Whenever if your enzyme have a two choice of substrate, say S1 and S2, so how to choose which substrate is most appropriate for that particular enzyme is based on the Km value. For example, in this substrate 1, the Km value say is 0.07, whereas the S2 have the Km value of say 0.1. Obviously, the S1 is the have more affinity towards the enzyme. So the enzyme substrate with the first substrate is always better than the substrate 2. So this is the application of Km. That is the reason why we are calculating the Km value. And what is the significant role of Vm? Vm, we all know that in enzyme substrate reaction between V and S, the Vm is calculated at the maximum velocity. So the enzyme is depends on how, based on the processivity of an enzyme, so we can find out how much product is produced with the particular enzyme. Here if you have two enzymes, one is like this, whereas another one second enzyme is like this with the same substrate. Now like, so we have this is E1, this is E2 with the same substrate. Obviously we from this graph we found that the E1 has a better enzyme with respect to that substrate based on the processivity of the enzyme. So this is the reason why Vm and Km is always first parameter that we need to calculate for enzymatic reactions. So this is the significance of the Vm and Km. Now we will see how to calculate this Vm and Km. First of all, we will see in the experimental way, then we will see some problem, right? So now we will see how to calculate the Km, Vm by using equation. So let me write the equation. So equation is nothing but V is equal to Vm into S divided by Km plus S. So the first way to calculate the Vm and Km with the help of the graph. So V versus S, so we know that you will get a graph like this. So how to calculate Vm? So Vm is calculated based on the saturation point. So this is Vm. So how to calculate Km? So in the previous lecture we saw that Km is equal to S when V is equal to Vm by 2. So you calculate Vm by 2 from this graph and extrapolate this. Whatever the substrate concentration at the intercept, this is what we call Km. So we can calculate Vm and Km based on this particular graph. This is called MM graph. But there is a disadvantage. One, this graph is a non-linear graph. So obviously the accuracy of these values from this graph is not adequate. So now how I can convert that graph into a linear graph? If I am able to convert the into linear graph, so we can able to calculate in a more accurate way. So the first method to do that, so there is a first method we call Eadie Hofstee method. So how to do that? So just we modify the MM equation in order to convert this into a linear form. How? Let me see. So this is your MM equation. Just cross multiply this. Right? You multiply it inside. So this become VKM plus VS. So I forget to put a bracket. Right? So now multiply, so divide this with the help of S. So it has become V by S into Km plus V is equal to Pm. From this you keep the V in this side. So you bring this one to the other side. Sorry. Minus P by S into Km. So in this, if you look at the variables, what are the variables? So this is the variable, and this is the variable, and this is the variable, whereas the other thing is a constant. So you can see this is like a straight line equation format. So this is y is equal to plus mx into plus c. So what is c? So c is Vm, whereas y is V, whereas x is this entire part. The V by S is nothing but x, and minus Km is your slope. So let me draw this, let me erase this. So if I am trying to draw a graph based on this value, right? So if I am trying to draw the graph, so what is the y-axis here? The y-axis is going to be V. What is the x-axis? The x-axis is going to be V by S. And what type of line we are going to get? We are going to get a line like this. Right? So based on this straight line equation, we can calculate the m value. The m value is nothing but the slope. The slope is equal to minus Km, whereas your y-intercept is equal to Vm. So the Vm and Km, if you draw the graph like this, V by S, so this is how you can calculate the Vm and Km. So this is the one way to calculate the mm constant by using Eadie Hofstee plot. Right? So next we will see the other two methods.